Okay, good morning. Welcome to
SuperMath number 3.
SuperMath number 3, lines and circles. So today there was an interesting question in your book, which was, if you have a circle, can you draw a line that does not touch the circle? You have a circle in the plane, can you draw a line that does not touch the circle?
Well, this line doesn't touch it.
Okay. Can you draw a line that touches the circle exactly once?
Well, it's tangent to the edge. It just skims it right there.
Okay. And can you draw a line that touches the circle twice?
There's a lot of those.
Okay. And so you asked a very interesting question that we're going to end up talking about today, if I can find an eraser. And what was the question?
Well, are there infinitely many ones that don't touch the circle? Infinitely many ones that just touch the circle on one point? And infinitely many ones that touch the circle twice.
Okay. And so there were infinitely many in each of those three cases, so what were you wondering?
But it seems like these are more. It seems like there's more of these.
Yeah.
But they could be the same.
They could be the same, could be more. Even there seems like there's infinitely many tangent lines too. Why?
Because there's infinitely many points on a circle.
It's infinitely
You can
many
just have a line on each point.
Yeah, and so what we were talking about before the movie, and since we have to wrap up, I figured we'd continue talking about it in the movie, is these questions about comparing infinite sets are pretty tricky questions, actually.
Well, infinities are tricky.
Yeah, infinities are tricky, and so what we were talking about was a simpler question, which is a very famous one. This infinity was kind of first studied and understood by a German mathematician named Georg Cantor. And what we just talked about is that the rational numbers, so of the form a over b, where a and b are integers, have the same number of numbers as the integers. And that's surprising because in between even just 0 and 1,
you have a lot.
there are not just a lot, infinitely many rational numbers. Here, a half, 2/3, 1/7, infinitely many. Even just between 0 and 1, and there's infinitely many integers. So it feels like there would be more rationals, but it turns out Cantor proved that it's the same. But he had a different proof to show there are more real numbers. Okay, so right before we started the movie, I had just asked you, what is a real number between 0 and 1 that is not rational?
I said the square root of a half.
You said the square root of a half, which turns out to be about 0.7. A little higher, but because what is 7 squared?
7 squared is 49.
So 0.7 squared is?
4.9. Well, 0.49.
0.49. It's almost a half, so it's about like 0.71, etc. Okay, but you're right, this is an irrational number. And what Cantor showed, which is a very, very famous proof, is if you tried to list out the real numbers, just like you can list out the integers, you'd always miss some number. And the way he did it is he said, take numbers between 0 and 1, like 1, 2, 3, 4, 5, 6, 7, 0.9, 2, 1, 3, 4, 6, 2, 0. Just tell me some numbers.
1, 7, 3, 3, 7, 2.
Okay, etc. And now here's what you do. So you made a list. So you say, hey, maybe I can list out all the real numbers, even just between 0 and 1. Just like we did, we could list out the rationals.
You always miss. There's infinitely many more.
Well, but there was infinitely many integers and infinitely many rational numbers, and we found a way not to miss. We got all of them. Okay? So here's the very clever argument. Cantor said, not only do you miss a number, I can tell you a number you miss. Okay? No matter what's on the list. He said, on the first number, look at the first digit. If it's a 7, let me make it so I change one of the numbers. If it's a 3, make it a 7. If 3, then 7. And if not 3, the not symbol in programming. If it's not a 3, make it a 3. Okay?
So all of them will end up being 7s.
Okay, so here is, what is this? The first digit is, the first digit of the first number is,
1, so it's not a 3.
okay, so we're going to make 0.3. The second digit of the second number is,
2.
so what are we going to do?
Make it a 3.
The third digit of the third number is,
3. So we'll make it a 7.
make it a 7. Okay, and we're going to go down our list this way, and we're going to get a number, 0.337, blah, blah, blah. But here's the interesting thing. In the first digit, it's different than the first number. In the second digit, it's different than the second number. In the third digit, it's different from the third number.
So we missed this one.
So this number is going to differ from the nth number in the nth digit. It's not going to be on our list. So no matter what list we make of real numbers, we're always going to miss. So you can't list out the real numbers. They're a bigger infinity.
To infinity.
Which is very surprising, right?
Yeah.
It's very surprising. So it's incredibly difficult to compare infinite sets. And it leads to some fun little paradoxes. Can you take that? But your question is a fascinating question. Are there more lines that go through a circle or more lines that don't go through a circle? Tough one to ponder.
Yeah.
Probably a little bit more advanced than a beginning geometry course. But a good thing to wonder about.
Yeah.
Alright. Good question. Good question.